Every measurement has some uncertainty, in which it is called experimental error. Another definition of it is the difference between a measurement and a true value or between two measured values. So why does experimental error occur? Experimental errors can occur due to a variety of reasons, like equipment not being calibrated correctly. Calibrations of equipment and laboratory glasswares are very important. It prevents us to make inaccurate measurements and experimental error. Then temperature fluctuations. And human mistakes are just a few things that can cause experimental error. Systematic errors, random errors, and blunders all leads to experimental errors. So what are the types of experimental errors? Experimental errors is classified either systematic or random. Systematic error, also called as determinate error. It arises from a flaw in equipment or the design of an experiment. Systematic error is a consistent error that can be detected and corrected. Random error. Random error are also called as indeterminate error. It arises from uncontrolled and maybe uncontrollable variables in the measurement. Random error has an equal chance of being positive or negative. R has an equal chance of being positive or negative. It is always present and cannot be corrected.
Ways to detect errors. First, analyze a known sample such as a certified reference material. Your method should reproduce the known answer. Number 2, analyze blank samples containing no analyte being sought. If you observe non-zero result, your method responds to more than you intend. Number 3, use different analytical methods to measure the same quantity. If results do not agree, there is error in one or more of the methods. Number 4, round-robin experiment. Different people in several laboratories analyze identical samples by the same or different methods. Disagreement beyond the estimated random error is systematic error. Ways to minimize systematic errors. Number 1, collect representative samples. Number 2, analyze standard reference material whose concentrations are known. Number 3, analyze blank samples. Number 4, use sample methods to make measurements. Number 5, participate in a round-robin study with other labs. And number 6, vary the sample size. Calibration of apparatus. By calibrating all the measurements, errors can be minimized and appropriate corrections are applied to the original measurements. Control determination. Standard substance is used in experiment in identical experimental condition to minimize the errors. Accuracy. Accuracy describes how close a measured value is to the true value. If a known standard is available, accuracy is how close you value is the known value.
Precision. Precision describes the reproducibility of a result. If you measure a quantity several times and the values agree closely with one another, your measurement is precise. If the values vary widely, your measurement is not precise. Okay, using accuracy and precision. The random error will be smaller with more accurate instrument, or measurements are made in finer increments and with more repetitively or reproductively precisions. Okay, samples of experimental errors. So in systematic errors are errors of precision, as all measurements will be off due to things such as miscalibration or background interference. So sample of a systematic error arises from an uncalibrated burette. The manufacturer's tolerance for a class A 50 ml burette is 60.05 ml. When you think you have delivered 29.43 ml, the real volume could be anywhere from 29.38 to 29.48 ml and still be within tolerance. And number 2, the random errors occurs due to the happenstance, such as fluctuations in temperature or pH. So different people reading the scale has different value. They report a range of values representing their subjective interpolation between the markings.